waste management. So as part of our mission, we help educate on various topics, PFAS being one of them, and with science sessions, in terms of what they are, why we structured them the way they are, these are sessions that are intended to be fairly short. They are going to be focused primarily on scientific research types of topics. We'll keep things moving fairly fast. The format of this is going to be a little different, perhaps, than normal webinars that follow a typical presentation with a slide presentation type of format. So this is intended to be more interactive. We will have groups of experts talk about things. For those of you who do attend these, we will receive a certificate of attendance following the email, and we'll have these in succession throughout the year. So stay tuned for other topics. We do have a number of science sessions planned beyond this one. One of the first ones is called Unnatural Selection, the Evolution of PFAS Policy, and then we'll get more into the science of things. So the session today and the session on policy are intended to really set up this issue so that later sessions get into more of the science of what's happening to help understand more how the waste industry is addressing the issue, how broader society is dealing with the issue, and moving forward. It is important to note that the science sessions as a entity are going to include a variety of topics, PFAS being one of the first topics out of the gate. But as we get further into 2021, we'll be looking at recycling topics, we'll be looking at composting topics, other waste management topics as we go along here. We would like to take a minute to thank our sponsors for our science sessions, Golder Associates, Labella, and Republic Services. Thank you all very much for supporting us today and in the future sessions coming up. A few housekeeping items here. Before we begin, I'd like to mention that all participants have been muted. If you have any questions for our speakers, please use the chat function. Questions will be addressed at the conclusion of the session, time permitting. And should you have a technical issue, please use the chat function and an EREF staff member will assist you. If you would like a certificate of attendance, be sure to attend the entire webinar, and a link to the certificate along with a brief survey will be sent to you along with the recording of the session early next week. So with that said, let me introduce our distinguished guests for today. We have Joe Benko, who is Director of Engineering for Republic Services. In his role, Joe supports the engineering department with all technical challenges regarding landfill construction, environmental remediation, compliance resolution, and regulatory strategy. He's been with Republic Services for over 20 years and holds a bachelor's degree in civil engineering from Notre Dame. Sam Nicolai is Vice President of Engineering and Compliance for Casella Waste Systems. He leads the team that manages the company's engineering, permitting, construction, and environmental compliance programs at solid waste facilities throughout Casella's Northeast footprint. He's got nearly 25 years of industry and consulting experience and has a civil and environmental engineering degree from the University of Virginia as well as Virginia Tech. And our third panelist is David Pepper, who is Vice President of Post-Collections for U.S. Solid Waste Operations at GFL Environmental and has 33 years of experience in the solid waste industry. David has a bachelor's degree in geology from Louisiana State University. It sounds like a great joke, two engineers and a geologist walk into a bar, and then you can fill that in. So we are grateful to have you all joining us today. And just a quick note before we get started. In the room when it happened, Industry Perspectives on PFAS is the title of our session today, because the issue arose not as a consequence of waste management activities, rather as the shadow of PFAS, due to the health and environmental concerns it raises, continues to grow. A number of industries that are critical parts of societal infrastructure like solid waste, wastewater, drinking water, found themselves in the room when the issue got significant attention from policymakers, regulatory agencies, and media. In this respect, the waste industry has been identified as having a prominent role in the management of PFAS contained in industrial wastes and manufactured products that are discarded by consumers. So let's just back up for a minute. Gentlemen, with you here, give me some perspective on the various issues that you all normally have dealt with and before PFAS arose as an issue, and maybe put that in perspective. I mean, how critical is the PFAS issue relative to the other things that you all are dealing with? Joe Benko, why don't you start us off with that?
Sure thing, Brian. Good morning, good afternoon, everyone. Happy to be a part of the panel. So really, you know, if you look at the roles I think all of us have, and myself certainly, we're charged with assisting our field teams with implementing construction, compliance, and any other issues that the company might run into across our footprint of facilities. And most of our challenges that we face in the day, I think, are well defined. You know, we all manage non-hazardous MSW landfills, and we're following a pretty prescriptive set of regulations within RECRA that lays out how we address problems and what it is we're trying to solve for. So from that perspective, I won't say the challenges aren't unique, but at the same point, there's a pretty well-documented playbook that we're all trying to follow when we solve these challenges. If you compare that to what we're seeing on the PFAS challenge, we're really seeing regulations and issues, technical issues, are evolving real time and at different speeds throughout the country as a lot of the efforts have been driven at a state level. So it's really unique from a lot of the other pieces we deal with on a daily basis, because we're not running a playbook yet, because the science and the other pieces are still unfolding sort of right in front of our eyes.
Okay, thank you. Hey, David, I think GFL is in a unique situation since one of the PFAS production facilities in the United States is right here in GFL's home turf of North Carolina. You want to give us a little perspective on how that particular situation perhaps brought PFAS onto your radar, and how you all view that relative to the other issues you all face?
Yeah, sure. I think Joe, generally prescribed, how we function and did that very well. I think our unique perspective, our moment in the room, if you will, kind of was thrust upon us in 2018 when the major manufacturer of these types of chemicals here in North Carolina was kind of brought to the forefront. A lot of publicity, a lot of negative publicity associated with that. And that began to trickle down to the landfill industry as time developed and people began to get an understanding that, landfill leachate could potentially be a source for these types of compounds. And so, it was at that point, really in 2018, that we began to get more involved in understanding, our role in this play for sure.
It's interesting that despite the fact that that had occurred in North Carolina, really the Northeast and some of the Midwestern states really took the initial lead from a regulatory and policy-making standpoint. And Sam, I know you guys have been dealing substantially with that. You want to weigh in a little bit on how the policy-making issues and the regulatory actions have affected Casella's waste management, and a little bit of your history on how this came to light for you all?
Sure. So, as you mentioned, several of the New England states have been fairly early in the process of identifying and evaluating these compounds. In a couple of the states in which we operate, there were fairly early investigations related to either a manufacturer or a similar facility where there were some groundwater impacts. And so I think that shone a bright light on the compounds in those states. And that's really circa 2015, 2016 at this point. And so certainly if you look into the research, the compounds have been identified for a while, and there's some data, especially overseas, where these compounds were on at least some folks' radar, but certainly the last couple of years, we certainly have seen the emphasis. And I think Joe mentioned, more than anything else, it's just the speed at which things have moved has made the challenges, made PFAS, I think, unique. It's certainly not the first emerging contaminant in my career to come out. It's not the first time we've seen changes that have been impactful. Things like federal MCL changing for arsenic, for example, was a fairly impactful issue a couple of years ago. So that's not unique, but just the speed that everything has rippled through both the technical side as well as our operational side, I think has been one one of the biggest challenges in dealing with these compounds, and probably will be for some time in the future.
So thinking about the holistic picture of solid waste management across different facilities, relative to what you just said, let's stick with you for a minute. What do you think are the primary challenges related to PFAS that maybe are different than some of the prior challenges you've dealt with along those lines? How is this unique, or is it not that unique and it's quite similar?
Well, I think the speed in which I talked about and sort of the bright light went on to the landfills pretty quickly, and there's been a ton of discussion about the landfill leachate, and certainly rightly so, given the presence of the compounds in landfill leachate. I think we're finding that when you step back and look at the larger picture, several states have done some fairly exhaustive sampling in their wastewater treatment facilities and are identifying the compounds in those locations. There's a lot of work going on right now in terms of looking at land application of biosolids and some of the impacts there. And I think we're finding kind of what we knew, which is these compounds are pretty ubiquitous, given that their presence is in the fabrics and the furniture and the car seats and all the things that we are working with in our daily lives. And so, it's not a solid waste problem right now. It's an industry problem. It's starting up at the manufacturing level, going down through consumers. And, we're in the fortunate or unfortunate place of sort of being at the end of the line here, trying to help manage these waste materials and dealing with the impacts. And so when we step back and look at that from a holistic standpoint, I think that will help us really identify the right avenues to move down in terms of managing these compounds. It's not simply go to the end of the line and treat it. How are we going to change the way we manufacture, use, and dispose of these materials so that we can address these compounds?
Yeah, that's a good point. These compounds have some unique properties, and we've seen the characteristics of these properties offer a lot of advantages to society. I mean, they're water repellent, they're oil repellent, stain repellent, flame retardant. They, as a result of their chemical makeup, offer a lot of conveniences to society, but they don't readily break down. And they've been detected nearly everywhere. So this is a chemical that really is there's no place, I think, on Earth now where it hasn't been detected. It's in our blood, and it's made in all kinds of different compounds. There are a whole host of compounds of consumer products that they're made in. And if we can advance to the next slide, that'd be great. That shows different compounds or different products that these compounds are part of. And they're everywhere, like you said. I mean, we have carpet, we have furniture, we have food packaging, and so forth. So they are really ubiquitous in society. They're then coming to the solid waste management industry in various forms. And so one of the things that's interesting to me is that these compounds were started being used around the 1940s. So they've been around for 80 years. Roughly speaking, and right now is the time that we're just starting to hear from it. Are there any specific things that you all are doing from an operational standpoint that might be unique to PFAS? David, is there something that you all are doing at GFL that is unique to PFAS management? Or are you handling it like any other emerging contaminants that might be out there today?
I think one thing we're starting to do is to take a look at, when we have large industrial generators of waste, we're starting to evaluate it for these compounds, their waste streams for these compounds, where we can identify a source in a situation like that. We're evaluating that as part of our industrial special waste approval process, and doesn't necessarily mean that they're excluded if it shows up, because, frankly, we're a part of the solution for the issues that these materials bring to the table. So, but it is something that we're taking a look at. So that's one aspect of some things we're doing.
Joe, how do you all deal with that? With all of these different products coming in, in a load. You could have anything that PFAS might be a part of coming in. Is there anything unique that you all are doing?
Well, I think it will vary depending on the location and depending on the waste stream. I think you have, as David alluded to, different sources. I mean, it's all over the place in consumer products that are coming into the landfills right now. And so to chase it just solely on the fact that it exists in the waste stream probably is not a real good ROI on that investment. So I think where we tried to be mindful and look at it is the potential waste streams that might be a large source, and that really gets into your remediation waste streams. And if you're getting requests to take on firefighting foam, I mean, that's an obvious, well-known source. And so it's more discussions around identified and well-documented streams versus looking across the whole inbound portfolio into the landfill, because it's going to be very prevalent within the waste that's coming in.
Do you all see specific types of non-MSW wastes coming in that seem to have or be more of a concern from a PFAS concentration standpoint outside of firefighting foam?
I would say that, just as we're becoming more aware of it as a cleanup industry, I mean, the DoD's been working to clean up bases, and a lot of the cleanup waste at those bases will include potential PFAS issues. So I think remediation waste is maybe one example on large cleanup projects where it's becoming part of the discussion and the narrative as it's part of cleanup targets and what they're chasing as the regulations evolve to set their cleanup target standards.
Okay. All right. So as far as what we should be primarily focused on in terms of treating PFAS, there is some various graphics out there that show freight transport of PFAS, and there have been some depictions that show PFAS coming into the solid waste management infrastructure. Landfills tend to be a primary poster child, if you will, for where PFAS ends up. And some of those graphics do show this potential for PFAS to be released into the groundwater or surface water. Now, the graphic that was put out by the ITRC has since been updated and to show that, to make a distinction between landfills that are unlined versus lined. And as far as that's concerned, can you all talk a little bit about the liner systems in landfills, and just give the folks who are on this call who may not be as familiar with liner systems a sense for what does lined mean versus unlined, and how does that become a barrier to PFAS release into groundwater or beyond?
Good thing, Brian. I'll start it off and throw it to the other folks for cleanup. Again, in 1993, the EPA rolled out the RCRA Subtitle D regs and basically required liners for landfills on a go-forward basis. And that's been really extraordinarily successful in terms of protecting groundwater across the country. So really that maneuver has required landfills going forward to have liners, which consists of clay and in many cases plastic, HDPE or other components put together with a leachate drainage layer over top. And so any water that's making its way through the waste and becoming leachate is then collected at a sump and taken out and treated instead of potentially flowing through the waste and contaminating any groundwater that might be under the facility. And as a result of that, that's been very effective in terms of protecting groundwater as a resource on a go-forward basis in the country. And it's protecting them from all kinds of different constituents that might leach out in leachate. And I think most of us on this call know that leachate can be a mix of all kinds of different constituents, and PFAS is included in that. And liners are seemingly very effective at making sure the leachate goes where we want it to, and a point where we can collect it and treat it. So I think that's That's an important component that's been around a long time, and that distinction of newer landfills that have been upgraded to the current regs really appear to be very effective in terms of protecting resources versus, older unlined facilities that predate those regs. That is a different story, but I think that distinction can at times not be well understood.
Dave, do you have anything to add to that?
No, I think that's a pretty good description. It's there is a distinction between the lined and unlined facilities, and I think Joe described it well.
Okay. Yeah, and that depiction of the success of landfill liner systems is certainly one that in some areas there's a significant amount of research that does exist, and in other areas perhaps more research is needed. I know EREF as an organization right now has a grant with the University of Virginia that's looking at addressing this very question. Is there any chance that PFAS would ultimately get through a liner system as it's engineered today for modern landfills? And that project just got underway not long ago. We've got another year or two, probably about a year before we see some of the results from that particular project that will document the extent to which PFAS might move through a liner system. But the previous research suggests that it would be very unlikely. But this is an example where making sure that the science is available to document that, especially as politicians get into this space. I mean, there were quite a few House committee hearings last year related to this, and the topic of landfills came up rather frequently. So, certainly the science needs to be available for policymakers to help aid in that discussion and document, whether there are any particular results that might impact how things are currently done. In that respect, as you noted, Joe, what comes out of the landfill is typically would need to be managed would be landfill gas, and in particular leachate. And so in that respect, should we be primarily focused on treating PFAS in landfill leachate and runoff from compost facilities or landfill leachate, or should the efforts be broader, looking to, say, recycling facilities and so forth? And Sam, do you want to address that one? I know you all have been following that space and as well outside of just the landfill setting.
Sure. So, certainly, the recognition that these compounds are in the leachate is going to result in the need for ongoing need, today and in the future, to ensure that those are at levels that are being properly managed. And I know there's a lot of work going on right now, some of which each of our companies is involved in identifying and really testing the most appropriate technologies for that. But certainly we recognize that these solid wastes that we are producing and are going to be producing for decades to come are going to continue to contain these compounds, and we need a solution in order to manage these compounds. We've done some work, as others have done, in looking at the mass that comes into a landfill and trying to determine how much is being sequestered within the landfill and how much is coming out into the leachate or into landfill gas or into emissions. And certainly more work needs to be done, but it appears that it's well in excess of 95% and way perhaps even closer to 99% of all the mass is really being sequestered. And certainly you're seeing differences in the long chain compounds versus the short chain compounds. And so I hear discussion of, PFAS is just washing through the landfills. That's, pretty definitively proven not to be true. So we know that the landfills can provide an important service in terms of taking these wastes and managing them appropriately. Now let's make sure that the leachate and if necessary, gas is being properly treated and ensuring that we're protecting human health and the environment. But it's critical that we continue to provide an important waste management solution to managing these compounds. Even if you could wave your magic wand and stop all the manufacture of this tomorrow, we're still going to see these compounds coming out of our waste stream for decades to come.
and thinking of it going into landfills, I mean, I know that leachate has been a significant focus at various technical conferences over the past year or so in terms of how do we treat leachate. In your eyes, where does PFAS leachate treatment stand in terms of its capabilities right now, either using installed technologies that already exist on site or maybe the on-the-shelf technologies? David, you want to kick us off on that?
Hey, Brian, I just to follow up on Sam's comments earlier to your earlier question, I think the answer to, is it just landfill leachate that we need to be focused on? I think the answer is no. I think we're starting to see some legislative activity. You mentioned politicians earlier. We're starting to see some legislative activity to try to begin to address sources. And Sam mentioned that, even if we were able to do something with sources today, there's still decades in the pipeline still working its way through the system. But I think it's important that we begin to take a look at that. And I think part of the reason I feel like that's important, and if it helps people to understand the area of leachate and its exposure, we conducted a study here in North Carolina with a significant amount of research with several landfills involved. So did the state of Michigan. And in both cases, the landfill leachate, while may have concentration numbers that might seem quite alarming, first of all, Sam mentioned that, significant amount of this material is being sequestered in the landfill. Secondly, what does make it through to the leachate, at least in our study, where we looked at, not only the contribution of the landfills to the wastewater treatment plants with their landfill leachate disposals being less, around 3% of the total mass coming into a treatment plant. So if you think about that for a minute, it's a very small piece, and in a lot of these cases, these wastewater treatment plants didn't really have any industrial dischargers upstream of their facilities. So what that tells you is it's coming from, household waste, and it's as you said earlier, in our blood, and it becomes part of the waste stream in that way. And so I think, for society to understand that this is not just a landfill leachate problem is an important thing for us to convey. And we want to make sure that people understand that, there are exposure pathways. And I think the more we can educate people, the more we can protect the health of the community. So I think it's important that we do all of those things. We continue to study leachate. We continue to study, treatment technologies that don't only just sequester it, but work towards trying to break the bonds and destroy the chemicals. So, certainly through our support of EREF and the work that EREF's doing through research with partners at universities and so forth, we hope to get there, but we're not there today.
Yeah, that's a good point. Joe, did you have anything to add on that?
Well, I think landfills have been, again, really successful at taking inbound waste and putting it where we know it stays. So I think they're well monitored, and to some degree, we know we've got the pathways pretty well mapped out in terms of, we know where the mass comes into the landfill, and, we know that the leachate coming out can be all collected at one or two locations through a sump and sampled there. So I think you've got groundwater monitoring. All those indications are, if anything's going on, it's very easy to detect and locate. And so I think maybe the biggest challenge is landfills become, your easiest full-scale laboratory to go out and look for components in the environment for PFAS. But, as David mentioned in the studies that have been done in terms of influent loading into POTWs, just because you're finding PFAS in landfill leachate, it may not be the main source in the particular environment in which the landfill is located. And it may be tougher to find in some of those other locations because you don't have those monitoring networks and other tools that you have at the well-designed and well-monitored landfills to go find it. So I think it's important from a regulatory perspective not to jump to the easiest solution, but to find the one that we're all after, and that is really sort of reducing any contamination sort of in a mass load throughout the environment.
I guess I would just go ahead, Sam. Sorry,
David. The data that we've all seen about the presence of PFAS in the blood of the average U.S. adult. The average U.S. adult has never been close to a landfill and has no exposure to landfill leachate whatsoever. So we know that the exposure pathways are occurring. There's work to be done there, but even the simple of sitting in the seats and wearing the clothes and walking across the carpets that we all have in our homes, appears to be one of the primary mechanisms that's causing that exposure. And again, landfill leachate didn't cause that exposure. Doesn't mean we don't need to look at it, but it does mean that we got to recognize all the other potential sources that these compounds are impacting human health and the environment.
Yeah, I was just going to add that the efforts that were enacted back in, I think, maybe the 70s, where these people and PFAS were, eliminated from being manufactured in the States. What we have seen through studies that have been done over a long period of time is that those concentrations and masses are being reduced in the waste stream and in society as a result of those activities. So while it's a long lead item, we applaud the efforts of legislators who are working in that direction. And obviously that impacts all of us. We love to wear jackets that keep us dry in the rain. But at the end of the day, those are things that we kind of need to evaluate as a society and decide, do we really have to have popcorn bags in the microwave?
And these are good points. And Sam, you bring up something that's very relevant, because there was a study that came out last year, maybe early last year. It was from Harvard, that looked at data from multiple research studies that looked at the relative pathways of exposure to humans. And thus far what they found, and I know there's a lot more research right now that's underway to further evaluate this, but they aggregated over a dozen studies looking at different forms of exposure. And while the numbers were pretty variable, on average what they found and is that 70 to 85% of exposure to humans was through ingestion, and 15 to 30% of exposure was through drinking water, inhalation, and indirect sources. And so, Sam, I think, and David, you both of your points, that suggests that, based on what we know today, which granted isn't nearly as complete in terms of the science that I would personally prefer to really make sure this is well documented, but it does suggest that from an exposure standpoint, the vast majority of exposure is occurring through ingestion, and the way that ingestion is defined is typically exposure as a result of eating food that may have come in contact with PFAS through the packaging that it's in and in other sources, whereas drinking water, inhalation, and other indirect sources seem to be a fairly small fraction of that. So maybe one of you all can sort of trace this down for us, because if we think about exposure via drinking water and inhalation versus ingestion, where does solid waste management fit into that, and how many degrees of separation are we talking about if we're thinking about leachate before it were to get to one of these points of primary exposure for humans, like drinking water? Does anyone want to take a stab at that?
I'll make a first stab at it. I would just say, in our specific study here in North Carolina, I mentioned earlier that we were 3% of the mass loading on the wastewater treatment plants in a particular river basin here. And the state agency here took a look at the total loading for those wastewater treatment plants, and at least in this part of the state, most of our drinking water is from surface water source. And so in this particular case, they took a look at, water intakes downstream of these wastewater treatment plants and assumed no sequestration in the wastewater treatment plant sludge, for example. Just assumed all the mass loading on the front end of the plant went to the river, and no drinking water advisory levels were exceeded. And so if you want to take that and then boil that back down to to the landfill leachate, where we were only 3%. I think, we've talked about landfill leachate being, a source for this, but when you take a look at it from an exposure pathway standpoint, in this particular study, it was a super minor source associated with the drinking waters.
Dan, you want to say something?
Well, I think David hit it spot on. In conversations and in meetings, I think we all have seen too often the leap from a concentration in leachate to a discussion about exposure in drinking water, really ignoring the path that a compound needs to follow. And to our knowledge, there's nothing unique about these compounds compared to the other compounds that we deal with that are present in landfill leachate. So they have to have a path, they have to flow in a certain direction and a concentration. And all the things we've talked about, the liner systems, the monitoring networks, the siting of our facilities, are done in a way to be protective. And ensuring that the leachate is properly managed means we're also properly managing the PFAS compounds. We can't simply leap from leachate to drinking water. And I think, there's no doubt that this is an area that will continue to be evaluated as we look at the different treatment options. But as David mentioned earlier, we know the material is coming from a variety of sources into these wastewater treatment plants, and it's going to be a holistic solution to identifying, that mass and, reducing it to the appropriate levels based on, the site and the state specific reasons and regulations.
Well, in respect to that, where are you all going in terms of treatment of leachate? Is it something where you're actively looking for ways to implement strategies that are more focused on PFAS removal? I say that in various conversations that we participate in, both in the waste industry, in the public, and with policymakers. What I found that is interesting is a perspective that PFAS can somehow be selectively removed from leachate and then dealt with through, I know the EPA, for example, has been exploring incineration or things like that. Is that a fair assessment? I think I know the answer, but I wanted to have you all address that. Joe, do you want to talk about that for just a minute?
Sure thing, Brian. I think if you look at landfill leachate in general, there's an awful lot of research and an awful lot of discussion about it because it's a pretty challenging liquid when it comes time to treat it. So it's a mix of everything that's leaching out of the waste. So it's not a single contaminant and it's not a single issue, and it can vary depending on, regionally what's coming into the landfill. So it's been a higher strength, industrial wastewater for some time. And certainly we're working on methods to treat it, but I think the challenge has been that there's an awful lot going on in that matrix with the liquid, and really finding ways to treat it is you can't focus in on that one constituent, especially at a part per trillion level, and ignore everything else that's already in there that can easily impact any sort of treatment technology. So I think working through it has been a challenge, and it will continue to be a challenge. And if you look at kind of where we're at with PFAS treatment as a rule, it's a lot of it's starting in, basically cleaning up drinking water and much, groundwater streams, which are much simpler to treat than what's coming out of leachate. And so the technology is evolving and certainly evolving every day. But when we get into landfill leachate, that's a challenging wastewater for sure.
Right, and that's a good point. I mean, as I look at this issue, if you have one whiteboard that has problems and you have one whiteboard that has solutions, it seems that we still have a lot more on the side of issues to address with PFAS than we do the solutions that are available to us. I mean, in that respect, how do we deal with the variety of things that are happening? Sam, you mentioned a holistic perspective, because it's really not, as you pointed out, Joe, it's really not just leachate that is something to deal with. I mean, there's legislative challenges, there's regulatory challenges, there's the technical aspects of things, and then you've even got consumer behavior coming in the mix. What happens if someone's cheeseburger wrapper that normally has PFAS doesn't have it anymore? Is society going to be okay with half of the slice of cheese sticking to their paper in the future if PFAS were banned? I don't know the answer to that question, but these are all relevant, I think, to that holistic perspective that Sam, you mentioned. And so in that respect, as leaders and participants in the waste industry, what avenues should be priorities for investigating and encouraging in order to better manage PFAS related to the solid waste part of the equation? Sam, you want to jump on that one?
Well, we certainly talked around it a little bit. We do need to start at the manufacturing level. Today, we have a voluntary ban of a couple of the compounds, not all of them, and not implemented widely and not relevant to overseas. So there's more work to stop it at the source. David mentioned earlier, you're seeing the declining concentrations in blood. That absolutely has to continue. The further we're able as a society to make advancements there, the quicker we'll start solving the problem. As I mentioned earlier, quicker I think is still decades to come, but certainly that will start there. Lots of states are looking at solutions that also involve trying to divert waste or identify certain types of waste materials and figure out if there are higher and better solutions. I think those are good things to look at. I think it's going to be very challenging given that the length and the breadth of the kinds of materials that we know contain these compounds. You can't simply take a single class of compounds and say, well, we're just not going to manage these, or we're going to manage them differently. It's certainly not going to be that easy, but certainly I think that needs to be part of the conversation. And can we try to reduce the mass coming into facilities or treat the mass in a different way? I think all of those are important aspects. And then I think the last point I would make, just to kind of tie on to what Joe was saying, I mean, the treatment, for the most part, most of the technologies are separation technologies. We're not actually destroying the compounds. We're just taking them from one media and putting them into another media. So if we're putting them on an ion resin, if we're putting them on a carbon, if you're running it through an RO and you're putting it in a separate stream, what are the management solutions for that other media? To me, those are big areas that need more work and really drive a lot of our treatment evaluations and how we're going to deal with these compounds.
So, David, you all want to jump in on that?
I'll just add, when you look at this, to use your analogy of in the room, I never saw the musical Hamilton, but understand the premise behind the analogy. And I think when you think about that for a moment as it relates to this subject matter. I suspect the founding fathers, when they initiated their Declaration of Independence and began the process, I'm not sure they had a full picture of where it was going to end up, and we're not there yet. We're going to continue to evolve. And I think to take that analogy and apply it here is appropriate because, as we stand here today, we have more information than we had 2 days ago. As the solid waste industry, we're part of the solution here. But it's a process. And as Sam said, we may be decades away from either developing a technology that destroys the compound. We may be 2 weeks away, who knows? But, I know EREF is doing a tremendous amount of funding, tremendous amount of research in this area. And obviously it's a worthwhile endeavor and a goal, but it's important. And I know in our case here in the Carolinas, we've seen a regulatory environment where there's been a recognition of the work that's been done. And understanding that we're not all where we would like to be, but there's a process involved, and that involves science and engineering and legislative activities and regulatory community all working together to try to make sure that we're pulling in the same direction, not against each each other or pointing fingers at each other. And so I think that's the tricky part of this, because obviously in today's world, there's a tremendous amount of opportunity for that. So we appreciate the opportunity to work together on these types of things.
That's a good segue, Joe. I know you have some firsthand knowledge in working with some of the efforts that EREF is doing related to advancing science and data. What information or data or science do you think would be transformative at this time that we're in right now? Kind of really still early on, as I view it, in the curve relative to understanding how we fully deal with the PFAS issue. But are there some specific gaps or specific research areas that you think could really help the conversation, as David kind of points to, that can kind of get everybody rowing in the same direction?
Well, thanks, Brian. I think to some degree, what I'm looking for in, we're not getting the easy questions anymore. No one calls up and asks what the level of PFOA is in a particular waste stream anymore. They're looking for the answers or data that informs answers to the bigger questions. So what do we do about it? Where are we going? And so I think where I'm hoping to see our research advance is maybe less about the detective looking for items and more about sort of what information do we need to help prioritize different management strategies? What do we really think from an exposure pathway presents the most risk to a health and human welfare perspective? So really less about the, identifying that it's there. I think we see it all throughout society. So I think it's time to move on to say, all right, how do we start coming up with a solution, and how do we holistically work together to manage that solution? Because when you think about the groups, it's not just about solid waste, it's not just about landfills anymore. It's about policymakers, it's about regulators, it's about wastewater treatment plants. It's about the municipalities that are having to figure out how to manage, providing utilities to their citizens and managing clean drinking water and taking care of their wastewater, and how they're going to do that with budgets and revenues and all that being what they are in the world we live in at this very moment. So I really think evolving to the next generation of research, which helps us inform some of the decisions that need to be made and the pathways and progress we're going to make, it's really what I want to see going forward.
Tim, how about you all?
No, I would agree with that. I think, looking beyond the detective mode and starting to look into what are the solutions. And, I think it takes on the form of reductions in, the way we manufacture, the way we consume, but also, technology as it relates to breaking chemical bonds. And so, I'm thrilled that as in the room, as this group and other of our peers are out there funding research in this area in an effort to try to accomplish those things. I think that's important.
I would add, we certainly want to make sure that we move forward with urgency. Our goal is not to say that we have to wait for years and years of data before we're going to do anything, but that we move forward in a way that is supported by the science of the compounds and the exposures, but that it's done, with a sense of urgency, so that, we are evolving and adapting as quickly as we can to ensure that we continue to provide the waste management solutions that we're really tasked with providing. And there's a balancing act there, right, of trying to make sure you make good data-driven decisions, but not taking too long to generate that data. And I think we're all interested in that, in trying to find, that nice balance between, we want good data, we want to make good decisions about what we build and where we build it and how we manage it, but we want to do it as quickly as we can to ensure that we're doing the right thing and managing these wastes like they need to be managed.
Yeah, and last month, EREF announced its second request for proposals related to PFAS research. We have a deadline of February the 5th to see pre-proposals proposals in to consider answering some of these very questions and addressing some of these issues that you all raised. So I'm noticing the time here, and we do have some attendee questions I wanted to get to. And for those of you who haven't submitted any questions and you'd like to, certainly use the chat function to do that. And I'll throw some questions at you all here from some of our attendees. I think this was touched on, but as far as, well, it was touched on a little bit. We kind of talked about POTWs, but as managers of the waste stream, how can landfills and POTWs work together to mitigate PFAS release to the environment? Anything, I know we touched on that a little bit, but there has been some discussion about the what's been called the co-dependency of landfills and wastewater treatment systems, since I think the estimate is about 60% plus of leachate that is generated tends to go to POTWs, and then the POTWs in turn many times will take the sludge, and many tons of that sludge ends up in landfills. So there is some circularity there. But do you all want to address that? Is there anything that could be done differently, perhaps, that could allow landfills and POTWs to work together more closely?
I know that we certainly. Well, go ahead, Joe.
Started off, Brian. I think recognizing that interrelationship exists is an important point. I think, it's not always, it's maybe a given to the three of us on the panel that wastewater treatment plants have sludge disposal, and landfills likely play a key role in that, as much as POTWs can be a great source of disposal for landfill leachate. So recognizing that there is that interrelatedness, that's not a given. And I will say that a lot of our conversations, when the first discussion point comes out of a primarily water focus, it's like, okay, there's landfills. We know that's a source. Boom. And we'll break the chain. We'll focus solely on the landfill. And very quickly, you can put a wastewater treatment plant in a very difficult position by looking to regulate only one piece of the loop. And so I think understanding how they're related is an important point. And then there are pieces that you can build off of kind of once there's a recognition of the full cycle, and there's different ways to address that from a wide open perspective. And Sam, maybe you were going to jump in on that, so I'll throw it your way if you want.
Well, I think you hit it well. We've certainly tried to explore partnership opportunities with the wastewater treatment plants. It's a unique relationship. They're often our customer in both directions in terms of managing waste as well as managing sludge. And then when you consider treatment options, the treatment of a liquid that's been through a biological process, at a wastewater treatment facility is very different than it is trying to look at the unique properties of leachate. And so in evaluating treatment technologies and options, that decision of where you're located and whether you're treating a single stream or a wastewater stream is critically important. And that's certainly one of the questions that we have tried to make sure that we're asking regulators. Let's not put a solution in place and then turn around the next year and realize that, well, the wastewater treatment plant has to come up with a totally different solution for the same problem. That doesn't make a lot of sense in anybody's book. And so, asking and those questions and communicating with all the various parties, including the wastewater treatment plants, I think is a critically important, part of our planning process.
I think once we shift the discussion too on some of our partnerships that we've explored, you shift the discussion away from just a concentration in leachate to a mass loading discussion. A lot of times, landfills are about entombing waste inside a fully sealed environment. So a lot of times we'll look at particular sumps, and we'll look at capping strategies and some other ways that maybe we can reduce the total mass load that is headed out the door, even if we can't necessarily manage the individual, concentrations within the wastewater. So there are options, but it does take a partnership approach, and it does take an eyes wide open discussion to really make progress. And
have you all seen, there was a question that came across related to biosolids and how much PFAS biosolids contain. Are you all doing anything related to managing biosolids in a unique way in terms of the potential for PFAS concentrations in it to be significant, or have you seen that to be the case, that PFAS concentrations are relatively high, and if so, is there anything different that you're doing in terms of landfill disposal?
I know we haven't done anything uniquely for individual streams. We've evaluated concentrations in sludge streams, understood that they're there, understood that the compounds that we're seeing are different in those streams than we are often seeing in the landfill leachate. But I don't think that, at least not yet, has translated into how you would manage those, individually from a different standpoint. I think we believe that the strategies that we use to manage biosolids within a landfill environment are good for PFAS containing biosolids in the same way that they would for any other kinds of sludge materials. Good mixing practices, good odor control, managing the volumes appropriately, placing them in the right locations within facilities, all of which are our strategies that we already use, for those materials by their very nature.
Okay, and I know we're running up on the hour, so I'm going to end with one last question and then turn it over to you all to make any final remarks. But we've had a number of questions come in related to the discussion earlier about sequestration of PFAS in a landfill. The questions relate to how definitive is the science on that? Is the information preliminary, and can anyone drill down a little bit more on where that information is and perhaps what needs to be done to further document that?
Sure. So I'll probably start there. The work that we did was really a mass based approach, trying to document at a particular facility how much mass was coming in based on average concentrations associated with waste materials. If you've ever been a part of a project that tries to do that, that is an extraordinarily complex situation, trying to assign average concentrations for average kinds of materials. There is no average in terms of what a landfill sees on a daily basis. But we feel like we did the best that we could to look at the kinds of materials that were coming in, use supporting data from waste studies that identified the levels of mass, the volumes of the different types of materials, so how much C&D and how much MSW, and try to come up with a pretty good number for the mass coming in. And then the mass coming out is, primarily what's in the leachate, given that the very limited data that's out there shows that there's very, very low concentrations, if at all, in any of the air emissions. And so when you do mass in and mass out, you can see that the vast majority of the mass is staying within the landfill. And even when you try to take into the time component, a landfill is going to go through years of closure and post-closure. Even when you try to evaluate that along with it, the vast majority of the mass remains in the landfill and is sequestered there. Does more work need to be done on this? Absolutely. And it's a difficult concept to measure, given the challenges that we have with this, especially on the front end, trying to come up with a good rate in terms of the mass coming in. So I'd love to see some more work if folks are looking at project ideas, trying to understand how much of that mass is coming in would help to answer that question. But we're fairly confident that the sequestration rate is extremely high for that mass coming in.
Okay. Gentlemen, final comments or thoughts that maybe we didn't cover that you'd like to share before we jump off here?
I guess I'll start real quickly by just saying, I'm encouraged that, we have this venue, the opportunity to kind of give a perspective that maybe some have not thought about. I think generally, I think we've kind of hit around this, but I don't know that we've said it per se. I think to the last question regarding between wastewater treatment plants and landfills. I think everybody understands this when you think about it, but because of all the initial work in this arena in the research area dealing with what we coined as detective work earlier as to where is it, really kind of showed landfills as sources. And I guess I'd like to leave folks watching this to say, we're not the manufacturers of this, nor are the wastewater treatment plants. We're simply, managing society's waste. And so I think that's an important thing for us to understand. Doesn't mean that we aren't at the table. It doesn't mean we aren't in the room. We certainly are, and recognize our role in helping to safely manage society's waste is what we signed up for. And so we're excited to be in the room. It presents a set of challenges when it's early on in the game like this. But I'm convinced that as we have with many other things, we'll figure it out and we'll resolve it. It will take some time, but I'm comfortable we'll get there.
And Brian, I'm excited going forward. You mentioned the targeted RFP that EREF has issued, and I'm looking forward to really seeing what comes in my role working with the board on that process. I'm looking forward to our research council meeting here in a few months where we'll be looking through what hopefully are some challenging and thoughtful proposals that come in as part of that process, and help inform us, to David's point, as we kind of wrestle through these issues, and I believe we will solve them. But we're looking for good input, and certainly want to make sure that our best brains are looking at that problem and giving us their thoughts in that RFP.
Yeah, that's a good thought. I mean, the train is moving fast, and making sure that the good science catches up to the policymaking conversation is absolutely critical. And this is an example where it is moving so fast on the policy side of things. I know a lot of people are scrambling to try to get some of the science on the table so that folks can discuss that. Not only EREF as an organization, I know the EPA is doing a lot of work. Other agencies are also doing a lot of work to try to address this. So, gentlemen, thank you so much for your time today. We appreciate you spending the last hour with us and giving us more details on what's happening with things in the solid waste industry. For those of you who are attending this, as a reminder, you will be receiving an email from EREF through GoToWebinar. That'll contain the recording as well as an evaluation. If you can take a few minutes to complete that, we would greatly appreciate it. And again, gentlemen, thank you so much. And for everyone else who's on the call, have a great day, and we hope to see you with the next science sessions here in a few weeks.